Hello students, today we are going to start our first chapter of chemistry, that is some basic concepts of chemistry. As the word itself says basic concept of chemistry, it means all the basic things we have to know in this chapter. Okay, so basic things are what? In brief I can say in this you have to study about chemistry, its importance, matter, how many types it exists, what are the physical states of matter, the laws, the law of chemical combinations, Gay-Lussac's law of volume, Avogadro number, mole concept. These all we have to study in basic concept of chemistry. So first I am starting from chemistry only. What is chemistry? We all are studying. What we are studying in chemistry, it is the study of matter. So matter is what? Anything which occupies space and has got mass. Okay, its composition, it exists in the form of what? In the form of elements, compounds and mixture, their properties and how the changes in combination in the composition takes place when the reaction occurs, and how there are the changes in the energy in different processes. So this is chemistry. So chemistry is the study of matter, okay, its composition, its properties and changes in the composition and the energy during different processes. Now, if we are studying chemistry, there must be some importance, isn't it? So some importance of chemistry, what it is, let us study in brief. First, in the field of medicine, I will say, it has given number of drugs to us, isn't it? Number of medicines we are getting because we are knowing the chemical composition. Okay, so here some two major drugs which has been mentioned in the book is in making the life-saving drugs like Taxol and cisplatin. Okay, this Taxol and cisplatin is what? Cancer saving drugs. And you all know nowadays how cancer, it is a deadly disease and it is affecting many people, and from these two drugs it can be saved. Next is in making a drug known as azithromycin. Okay, in short we say AZT. Actually this drug is used in the curing the AIDS patient. Okay, now chemistry, when we are saying everything from the morning till the night, this chemistry comes in between. As soon as you take the toothpaste, as soon as you have your food, as soon as you use the soap, everywhere this chemistry comes. Even in your body, during the digestion of food, during thinking, everywhere the chemical reactions are taking place. So chemistry is present over there. Now in industries, in the manufacture of what? It is used in the manufacture of synthetic fibers like rayon, nylon, Decron. These all are what? Synthetic fibers. We use it at clothes, but these are all artificially made, and this is being made with the help of chemistry only. Plastics, when we are saying like Bakelite, polythene, these all are due to chemistry. Paints, dyes, everywhere the chemicals are there. In our daily use, as now I have said to you, the soaps, paper, cosmetics, these all consist of different chemical compositions. In the agriculture, it is used for as chemical fertilizer like urea. By knowing the chemical composition, we can make these fertilizers. Insecticides, also by knowing the chemical composition, it can be used, and it is used to what? To kill the insects, pests which grows on the crops, on our crops, and the example is of DDT. Then it is also used in making preservatives like sodium benzoate. This is a common preservative which we use in our houses for pickles, sauces, everywhere, everything. Okay, so these all need the help of chemistry to be formed, and so here chemistry plays a great importance. Now let us try to understand matter. Okay, so matter basically it is divided into two physical state and chemical state. The nature of matter is divided into two, physical state and chemical state. So physical state, when we are talking, this matter is divided into three, that is solid, liquid and gas. So this matter can exist in the form of solid or in the form of liquid or in the form of gases. Okay. Again, I will like to say you about matter. What is matter? Matter is anything which occupies space and has got mass. Okay. So everything around us is matter only, and it exists in the form of solid, liquid or in the gaseous form. So basically, what is the difference between this solid, liquid and gases? When we try to see the arrangement of the molecules in case of solid, we can see that it is too close to each other. Liquid, you can see that it has got small space, not more, only small spaces are present in between the liquid molecules. But in case of gaseous molecule, we see the space between the particles are more. So here you can see, in solid you can see the space between the particles is not at all, or you could say that it is not there. The interparticle forces now will be more, and the particles are closely packed in case of solid. And here you can see the particles are not so closely packed, it has got space. So here interparticle forces are less comparative to solid. But when we are talking about the gas form state, you can see here the space is more, so interparticle forces will be what? Less. So here, as the space is not there, it cannot move. It can only vibrate in its own position. But here the particles can move, but to a less extent. But in case of gas, the particles are free to move. When we talk about the compressibility, the solids cannot be compressed. But here liquid can be compressed only to a certain extent, and gaseous can be compressed to a larger extent by applying what? Pressure, and by lowering the temperature. So this is about the solid, liquid and gases, its properties this matter have when it is in the solid or in the liquid state or in the gaseous state. Whose density will be more? The density of solid will be the most, and then the liquid, and then the gaseous form. I said to you right now that yes, solid cannot be compressed, but when we take the example of a sponge, it can be compressed even though it is a solid, because it is because of the nature of the sponge that it has got small pores between its molecules of the particles, and as the result air occupies that space, and this is why it can be compressed. Now this is all about the physical state of matter. Moving on to the chemical state of matter, here the matter is divided into what? Two, pure substances and mixtures. When we are saying pure substances, it means it is consisting of some particles which are fixed, and here it is not fixed. Pure substances again divided into elements and compounds. So what are elements? When I say sodium, sodium is an element, isn't it? And its atom consists of how many electrons? 11 electrons, isn't it? So this will consist of 11 electron only. If we are saying 12 electrons, then that elements becomes what? Magnesium. So elements, they consist of only one type of atoms in it, and it cannot be divided, or it cannot be simplified by any physical means. If it is done also, it will be broken into its own entities. What happens in case of compound? Compound, here two or more elements are combining together to form a compound. In this, the elements are in a fixed ratio. Like compound, very simple example, I can say U of NaCl. This is a compound. This is made up of what? Sodium and chlorine, isn't it? Here the ratio is fixed. It is not that if I can write the compound name NaCl2 or Na2Cl2. Okay, this will become wrong. So here the proportion of the element is fixed of sodium and chlorine. So it is also a pure substance. Okay. So here when we are talking about elements and compounds only first, if we are saying it, it is consisting of only one type of entity. But here it is consisting of different elements which are being combined together in a fixed ratio. Here we cannot get this by any physical means. Here also we cannot obtain it by any physical means. And here you can see in case of the elements and the compounds, it remains same even though if it is being simplified. Now if I am talking about these compounds, when these compounds are being, these compounds are being formed from the elements, isn't it? So a simple example we can take is of what? Water. We can see in this what happens if H2 reacts with O2, okay? Electric arc is supplied, you get what? H2O, isn't it? So you get what? H2O. In this you can see these two different elements combined together to form a single compound. We are seeing about this hydrogen and this oxygen. They are all combustible gases. Here what happens, this all supports combustion, hydrogen also, oxygen also, but when it forms water, does it? It doesn't. So in compounds what happens, the elements which are reacting forms the compound which have the properties entirely different from which it was in the elemental form. Okay, now come to the mixture. Here we have seen that they are fixed, they are in a fixed proportion like compounds, and here it is fixed only. The element of sodium will be always the element of sodium, it can't becomes magnesium. But in case of mixture we are seeing two or more different elements or different substances are combined together without any fixed ratio. Okay, so this mixture is, you can take example of anything like sugar and water, sand and chalk powder, and sand and mud. These all are what? The example of mixture. This mixture is again divided into two, that is homogeneous mixture and heterogeneous mixture. Homo means same, hetero means different. When we are talking about homogeneous mixture, it means in this the components are in the even form. For example, if we take sugar and water, when you dissolve sugar and water, can you make out the sugar and the water individually? No. So that is an example of a homogeneous mixture. But when we are talking about a heterogeneous mixture, here all the components, they can be made out from by seeing it only. For example, you can take the example of sulfur and iron. You can take the example of pebbles and mud. These all are example of what? Heterogeneous mixture. This is all for today. Take care.